Hey, what's going on, everybody? Today we're talking CRISPR Therapeutics stock, ticker symbol CRSP. As a disclaimer, this is not investment advice. This is just a research video that I put together meant to be educational as well as entertaining. We're going to take a quick look at a few different news clippings and articles surrounding the company. We're going to hear from Dr. Jennifer Doudna, one of the inventors of CRISPR-Cas9, and then we're going to take a quick look at the stock. This video is being recorded Monday morning, September 21st. The year 2020. Please enjoy.
Today, most medical therapies aim to treat diseases by targeting abnormal proteins associated with a disease. Usually, these abnormal proteins exist because of mutations in specific genes in a patient's DNA. In the past, we have not been able to alter these genes directly to address the root cause of a disease. However, a novel gene editing system known as CRISPR-Cas9 may allow us to modify, delete, or correct specific areas of our DNA in order to treat these diseases. The system is comprised of two parts: Cas9, an enzyme that cuts DNA, and a guide RNA whose sequence directs Cas9 to a specific location in the DNA where the edit should be made. Cas9 associates with the guide RNA to form a complex that can be easily and precisely targeted to a desired site in the DNA. The CRISPR-Cas9 gene editing process begins when the complex recognizes and binds to a short segment of DNA adjacent to the target site. This initiates unwinding of the DNA helix, which allows the guide RNA to pair with a specific target sequence in the DNA. If the sequences pair precisely, Cas9 cuts the DNA, forming a double-strand break. Our cells respond to such breaks by activating natural DNA repair pathways. In some cases, a process called non-homologous end joining results in the addition or deletion of a few base pairs, which disrupts the original DNA sequence and can cause gene inactivation. A larger fragment of DNA can also be removed by using two different guide RNAs to target separate sites on either side of the desired deletion. Cleavage occurs at each site, and the repair process joins the separate ends, thereby deleting the intervening sequence. Corrections to DNA can also be made by adding a DNA template along with a Cas9 guide RNA complex. The template is designed with sequences that exactly match the DNA adjacent to the target cut site. Through a process called homology-directed repair, the cell uses the template to repair the break, thereby replacing the faulty DNA sequence or even inserting a new gene.
A few years ago, with my colleague Emmanuel Charpentier, I invented a new technology for editing genomes. It's called CRISPR-Cas9. The CRISPR technology allows scientists to make changes to the DNA in cells that could allow us to cure genetic disease. You might be interested to know that the CRISPR technology came about through a basic research project that was aimed at discovering how bacteria fight viral infections. Bacteria have to deal with viruses in their environment, and we can think about a viral infection like a ticking time bomb. A bacterium has only a few minutes to defuse the bomb before it gets destroyed. So many bacteria have in their cells an adaptive immune system called CRISPR that allows them to detect viral DNA and destroy it. Part of the CRISPR system is a protein called Cas9 that's able to seek out and cut and eventually degrade viral DNA in a specific way. And it was through our research to understand the activity of this protein Cas9 that we realized that we could harness its function as a genetic engineering technology, a way for scientists to delete or insert specific bits of DNA into cells with incredible precision that would offer opportunities to do things that really haven't been possible in the past.
This is a human embryo, and inside it is the blueprint for life. DNA. Half from its mother and half from its father. But imagine if science could intervene to add more DNA, or even remove it. Imagine we could prevent genetic disease, or eliminate certain traits by changing the blueprints inside the very earliest stage of human life.
Two beautiful little Chinese girls named Lulu and Nana came crying into the world as healthy as any other babies a few weeks ago.
When a Chinese scientist announced he had created the first living and breathing genetically modified babies, the scientific world reacted with shock and disdain.
The announcement by Dr. He in China came as a great shock and a surprise, and as a truly unfortunate development.
Gene editing brings with it a host of questions about morality, the power of science, and the potential for harm. So what exactly is gene editing? Who's doing it? And where to from here? Genes are sequences coded into strands of DNA that determine our traits and appearance, and in some cases, the diseases we may get. Scientists are able to edit these sequences to change the expression of an organism's genes. For example, they could delete a gene responsible for the development of a disease, or even alter its appearance. The technique Dr. He reportedly used for his experiment is known as CRISPR-Cas9. And while gene editing technology has been in development since the 1970s, CRISPR has become a more precise and cost-efficient means of editing genes. Scientists in London used it to find a key that could wipe out the world's mosquito population. And researchers in New York have used it to grow tomato plants with fewer excess branches. The products of these advances are at this stage confined to labs. For human DNA though, its potential to counter genetic diseases has made a compelling case for its continued use in research projects. Labs around the world are looking at how the technology could be used to eliminate diseases like haemophilia or HIV. Scientists have used CRISPR to create modified genes that can be injected into humans to treat diseases. In 2016, Chinese scientists used CRISPR-modified genes to switch off genes in cancer patients that prevent their immune systems from attacking their disease. But at the forefront of gene editing technology is experimentation on human embryos. Before Dr. He's revelation, this had only ever been attempted in the lab. Scientists have successfully eliminated genes that lead to diseases in non-viable human embryos, but never on one intended for birth. Most scientists urge a take-it-slow approach to using CRISPR technology to alter genes in humans. It's a complicated process, and editing genes can have unintended or unknown consequences. It's possible for scientists to attack the wrong section of DNA, or simply not know precisely what altering genes could do.
This type of science is moving much faster than the regulatory mechanisms that govern it.
They came out with a policy statement saying that we're not quite ready to try this yet in babies and in ways that can be passed down to future generations. We simply don't know enough about whether it's safe.
The power and scope of gene editing is advancing rapidly and in potentially unpredictable ways. But are we ready to tackle the profound ethical questions that come with powers we are yet to fully realise?
So this company, this technology, this science is pretty controversial. To me, I find it very interesting and fascinating. But let's take a quick look at this article from the American Banking and Market News, where CRISPR Therapeutics director sells 1.95 million in stock. This article came out September 12th. CRISPR Therapeutics AG director Bradley J. PhD Bolzan sold 22,845 shares of the company's stock in a transaction dated Thursday, September 10th. The shares were sold at an average price of $85.36 for a total transaction of $1.95 million. So a little insider selling, I see. Interesting. CRISPR has been the topic of a number of recent analyst reports. Oppenheimer began coverage on shares of CRISPR Therapeutics in a research note on Monday, July 27th. They set a buy rating and a $105 price target on the stock. Chardon Capital lifted their target price on CRISPR Therapeutics from $72.50 to $100 and gave the stock a buy rating on Tuesday, July 28th. Citigroup reiterated a sell rating on shares of CRISPR Therapeutics, and Wells Fargo lifted their price target from $95 to $110 and listed it as overweight. Interesting, very interesting. Okay, let's take a quick look at CRISPR Therapeutics chart. I'm getting this chart from a Seeking Alpha article that I will leave in the show notes. I am going to just bring to your attention the golden cross that occurred back in June. We see that the 50-day moving average crossed above the 200-day moving average, setting up a potential bull market. So let's take a quick look at what the Golden Cross means. And after the video, you'll pretty much get an idea as to where my head is at. For any time that the price from here on out takes a dip, it's a great buying opportunity. So let's take a quick look at Investopedia, and it breaks down what a Golden Cross is.
A golden cross forms on a graph when a security's short-term moving average crosses its long-term moving average. Moving averages, which measure a stock's average closing price over a period of days, are studied by technical traders who analyze trends in stock prices. You'd see a golden cross on a graph when a stock's 50-day short-term moving average crosses its 200-day moving average. Many technicians see a golden cross as a sign that a stock's value is headed higher. If a stock's performance continues to lag and no golden cross appears, its moving averages will remain roughly parallel to one another. A golden cross can also be a promising sign for an economy, as it may precede a bull market. Keep in mind that investors can choose arbitrary time frames to make a golden cross appear. A golden cross won't reveal whether or not investors intend to sell their shares.
Your extracted eggs, Marie, have been fertilized with Antonio's sperm. After screening, we are left, as you see, with 2 healthy boys and 2 very healthy girls. Naturally, no critical predispositions to any of the major inheritable diseases. All that remains is to select the most compatible candidate. First, we may as well decide on gender. Have you given it any thought?
We would want Vincent to have a brother, to play with.
Of course you would. Hello, Vincent. You have specified hazel eyes, dark hair, and fair skin. I have taken the liberty of eradicating any potentially prejudicial conditions, premature baldness, myopia, alcoholism and addictive susceptibility, propensity for violence, obesity, etc.
We didn't want, diseases, yes, but...
Right. We were just wondering if it's good to just leave a few things to chance.
You want to give your child the best possible start. Believe me, we have enough imperfection built in already. Your child doesn't need any additional burdens. And keep in mind, this child is still you. Simply the best of you. You could conceive naturally 1,000 times and never get such a result.
I feel proud, actually. I feel proudest.
The doctor who sparked global outrage by claiming to produce the world's first genetically modified babies faced his peers for the first time at this conference in Hong Kong.
As you can see, there's a big demand to know exactly what you did.
How you understand your responsibility to these children.
He was grilled by bioethicists, regulatory experts, and fellow doctors, but he remains sketchy on the details of his experiment.
I don't know how to answer this question from my eyes.
There has been a failure of self-regulation by the scientific community.
Shenzhen-based He Jinkui used a gene editing technology called CRISPR to engineer twin girls whose DNA was designed to resist the HIV infection.
The world has moved on to the stage for embryo gene editing. There will be someone somewhere who is doing this. If it's not me, it's someone else.
The news of the birth startled the scientific community.
The general feeling amongst the scientific community is that we shouldn't go ahead yet, but you went ahead without really discussing with people. That's how it seems.
I also consulted with several experts.
As someone who's been involved in the genesis of the CRISPR-Cas9 gene editing technology, I feel deeply disturbed. It's inappropriate and something that we have been working hard to avoid.
Why you choose to cross this line?
What is our responsibility as scientists and doctors?
May we know your future medical care plan for these babies?
How did you convince the parents?
Scientists here are worried about the safety of the CRISPR technology, and many cast doubt on whether He really did what he claims. His experiment would be banned in many places such as the US. For his part, He says he supports using gene editing for diseases and not for improving humans. He also claims that there is a second woman carrying a genetically modified baby in China.
Are there any current pregnancies with embryos that have been genome edited as part of your clinical trials?
There's another potential pregnancy.
Chinese scientist who genetically edited babies gets 3 years in prison. This article is taken from the New York Times. I just typed in this Dr. He, and wanted to find out a little bit more about him, and then this popped up, so I had to put it in here for sure. Beijing, a court in China on Monday sentenced He Zhenghui, the researcher who shocked the global scientific community when he claimed that he had created the world's first genetically edited babies, to 3 years in prison for carrying out illegal medical practices. So I'll leave in the description notes when this took place. Obviously, it's already occurred, so there's that. In the city of Shenzhen, found Dr. He guilty of forging approval documents from ethics review boards to recruit couples in which the man had HIV and the women did not. Xinhua, China's official news agency, reported Dr. He had said he was trying to prevent HIV infections in newborns, but the state media on Monday said he deceived the subjects and the medical authorities alike. Pretty interesting, pretty gnarly. Let's take a quick look at this article, this video clipping of somebody who really enjoys gene editing.
Josiah Zahner thinks everyone should be able to change their DNA.
For us, the frogs are a way to teach people actual genetic engineering and gene therapy without harming an organism. The step right before people doing genetic modification on humans if they wanted to.
Josiah is a very controversial figure. He's got a scientific background with a PhD in biophysics, and he spent 2 years as a research fellow at NASA. But he left to start a company called the Odin. He sells kits to help anyone modify organisms for as cheap as $30. That's because he wants genetic engineering to be decentralized, in the hands and homes of everyone.
I think everybody's worried about the risks of genetic engineering and how it's going to hurt people. And nobody's worried about the risks of what's going to happen if we don't allow people to do genetic engineering. Because the problem isn't going to be like, oh man, that person has way too many enhancements or doesn't. The problem is going to be, is it an equal playing field? Does everybody have access to this technology?
It's a provocative idea. It's also dangerous. And it's becoming possible because of CRISPR, a gene editing technology that can find and cut a sequence of DNA in a cell and replace it with another. It can achieve in days what used to take months, with precision and at a fraction of the cost.
If it wasn't for CRISPR, I don't think my company would be possible.
A few years ago, George Church, a pioneer of CRISPR, signed on as an advisor to the Odin. But even he's acknowledged the risks inherent in DIY genetic engineering. Leading researchers say the technology is still too new to use on humans without potentially harmful consequences, and that the way Josiah promotes it is reckless.
This is Josiah Zahner, coming straight to you from my garage lab, and I want to talk to you about how to genetically engineer a human being.
Josiah is famous in the world of biohackers, people who experiment on their own bodies and other organisms outside of traditional labs and institutions. He's gotten a lot of media attention for his very public DIY stunts, like when he injected himself with CRISPR while giving a talk at a synthetic biology conference.
This will modify my muscle genes to give me bigger muscles. Did that just quiet everybody? Sorry.
The month after Josiah's injection, the FDA issued a warning that, for safety reasons, it's illegal to sell gene therapy products for use on humans. Earlier that year, German authorities restricted imports of the Odin's CRISPR kit, reporting that it was contaminated with disease-causing bacteria. Despite the warnings, the Odin has sold tens of thousands of CRISPR experiments.
Don't tell anybody. These party lights are actually really special. We use them for DNA visualization or fluorescence visualization, 50-cent lights. And they work just as well.
You can't make an effective human gene therapy from just what's in these kits. You'd need more skills and supplies. If someone decided to inject themselves with what they can produce from the kit, they risk a potentially deadly reaction.
So if you don't purify it properly, you're just basically injecting yourself with something that can cause an immune reaction. The majority of people probably won't kill them, but that's just the majority of people.
The Odins started selling kits in 2016. Last year, Josiah says, they made over $500,000. He insists that by making gene editing available to as many people as possible, he's also helping to advance the science.
What are we all so afraid of? And I think that question kind of comes down to we're afraid to change what it means to be human. Like a clear-cut definition of a human being is male, female, they have kids and procreate. And once you start straying outside those lines, people get more and more uncomfortable. And I think genetic engineering is still at that place where everybody thinks it's going to cause the zombie apocalypse. Sometimes I still am afraid, but it's not a fear of something bad happening necessarily. It's more of a fear that you can't control it.
Josiah's public CRISPR injection doesn't seem to have done much to him. He doesn't regret doing it, but says he was surprised by the reaction he got in the months that followed.
Alright, so I'm going to try to shoot to do half of it on one side of my stomach and then the other half on the other side.
After I injected myself with CRISPR, the next biohacker to inject themselves was a month later. I thought it would be years.
And he admits his stunt might encourage people to do something dangerous, but is still wrestling with his own responsibility.
People are oh, I want to inject myself with all this stuff, even though I have no idea what I'm doing or what I'm injecting myself with. And I don't know, maybe that's good or bad, but you never want people to get hurt, or you never want your actions to have a negative impact on people.
You see, now that is the passion of an individual who sees this type of science as very beneficial. Obviously, right? The innovation that this guy, started his own gene editing kits, his own CRISPR kits. I think that's pretty cool. So, again, I know that this is a controversial topic, and I'm not trying to be political or controversial. I'm just laying it all out there. Let's take a quick look at my trading view. 6-month trading window of CRISPR Therapeutics from its March lows down in the 30s to where we're currently at in the mid 80s. Highlighted some levels of support. It broke out of a prior resistance level of the high 60s, low 70s. So right here I am going to lay out a new level of resistance in the 90s, the low 90s. And if it can break out of this resistance level and make this a future level of support, then I will still feel that it's going to continue its stair-stepping pattern of ascension. I think that once again, from its March lows to where we're currently at, it's had a nice run. There's been some pullbacks with the earnings reports, but then it kind of consolidates and then it continues to run. We've been having a little bit of a pullback lately, especially with big tech, a little bit into some cloud computing, some biotech, so perhaps some more innovative technologies and some innovative companies are starting to, I guess, sell off, right? We read the report where an insider was selling a lot of their shares. So again, I think that if we can make a future level of resistance become a level of support, then I continue to see it grow. And again, I'm just showcasing here the earnings reports where every time that, usually it can go either way, but I think that once you hear news about something, then you tend to, or at least people tend to sell their stock, and then they wait around for a rumor if something's going to happen, and then they buy, right? You've heard the saying, buy the rumor, sell the news. So I could definitely see where something like that takes place in a company, in a stock like this. So I think I will leave it here. Thank you for your time. I really do appreciate it. Please continue to like, share, and subscribe. We're doing really good. I really do appreciate all of the comments, all of the likes, all of the subscriptions. I really do appreciate it, y'all. If there's another company or ETF that you'd like to see me research, just leave it in the comment section below. I'll try to get to it as fast as I can. All right, well, until the next one, y'all take care.